What up, geometry students? We are going to review this 205 practice is really unit 2 up to now practice. We're going to start with simplifying some square roots. When we're trying to find the largest perfect square, like 4, like 9, like 16, like 25, where do these numbers come from? These are perfect squares. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, etc., etc. And we are going to get our calculators out and start dividing our numbers by these perfect squares until we find something that fits nicely where we can rewrite root 84 as root 4 root 21. Now you should think about root 21 and realize 21 is not divided by 4. 21 is not divided by 9. It's not divided by 16. So this is actually simplified root 21, but the square root of 4 can be simplified to be 2. Okay, for 12, we know that 4 times 3, and I pick 4, not 6. I don't pick 6 and 2. I said 4 and 3. Root 4, root 3 is root 12, so 2, root 3. Root 3 can't be simplified. Root 4 is 2. Let's see, 96. 96 is up, so I'll take 96. I'll divide it by 49. Nope. 96 divided by 36. Nope. 96 divided by 25. Nope. 16. Yes. Okay, so I see that root 16 times root 6 is root 96. Root 6 can't be simplified, but root 16 is the number 4. So 4 root 6 is root 96. 112 divided by 36. Nope. 112 divided by 49. 112 divided by 64. 112 divided by 16. There you go, another 16. Square root of 7 can't be simplified. Square root of 16 is 4. 108. Try 49. Nope. Try 64. Nope. I should put those numbers down like 49 is 4 squared. 64. 49 is 7 squared. 64 is 8 squared. Try 16 again. Nope. Try 9. Ooh. Did I miss? Oh, 36. Sorry. 108 divided by 36. So root 36, root 3. Root 3 can't be simplified. Root 36 is 6. 6 root 3. What happens if you have a number in front? Well, remember that this is multiplication, so it's 2 times root 18. Root 18 is root 9, root 2. So this becomes 2 times, the square root of 9 is 3. Square root of 2 is 2. 2 times 3 can be done. It's 6. 6 times root 2 can't be done. You can rewrite it as like root 36 root 2 and make it root 72, but we're good with that. All right. Now, the next series of questions is just the same questions over and over and over, where we have 2 points, which creates a line segment. And we want to find the midpoint of the line segment. We want to find the slope. We want to find the equation of the perpendicular bisector. We want to find the length. So we can visualize the line segment. We realize that if we want, we can create a right triangle. I mean, we do want. Where we have an easy horizontal length to be found and an easy vertical length to be found. We like to put the points on top of each other to help us visualize the change of x, or the x displacement, or the x distance being 5, negative 3 to 2, and 1 to 5 is 4. So I have a horizontal length of plus 4, I have a vertical length of plus 5. Now, if I wanted to go to the midpoint, I would go halfway. Now, going halfway, instead of adding 5, I'll add 2.5. If I add 2.5, I'll get negative 0.5. Instead of adding 4, I'll add 2. I get to 3. It's easy to find the midpoint that way. You could also find the average of the two numbers by adding them together and dividing by 2. Cool. I love putting the numbers on top of each other because it really gives us everything we need. Because the slope is the change in the y's over the change in the x. The 4's over the 5's. This is the y's per x's. 4/5 of a y per x, which allows us to find the equation of the perpendicular bisector. The slope of our perpendicular line is kind of the symmetrically flipped slope of the original line segment, -3, 1, and 2, 5. So if the slope of the original line segment is 4/5, the perpendicular line will be -5/4. We know it'll go through the point -1, -1/2, 3. We'll use the equation y minus y1 equals an m times x minus x1. And we have the midpoint as the point that bisects or splits our line in half. So I'll have y minus 3, I'll have -5/4, I'll have x minus -0.5 or x plus +0.5. And finally, how do we find the length of this line segment? Well, this is where we break out Mr. Pythagorean theorem. A squared plus b squared equals this diagonal length squared, the horizontal, the vertical, the two legs of our right triangle squared equals the square of our line segment length. So I have 16 plus 25 equals c squared. 41 equals c's square. We will square root to find c. We will attempt to simplify the square root of 41. Divided by 4, divided by 9, divided by 16. None of them work, so this is perfectly simplified. Okay? Five, 1, 2, -3. Stack them on top of each other. Got 5 to 2 is -3. 1 to 3 is -4. If I were to go to the midpoint, I'd subtract 1.5 from 5 to get 3.5. I'd add 2 to get 1, so I have the midpoint of 3.5, 1. Are there teachers in there right now? There's teachers in there still. My slope is the change in the y's over the change in the x's, so I can see I have this down 4 down -3. Well, that's the same as +3 +4. So I would change this negative divided by a negative into a positive or a positive. Equation of the perpendicular bisector, my slope would have to be the flip, so whatever was the x change becomes the y change and vice versa, and the opposite. So that will be my slope of this perpendicular line. And I have my y minus my 1 and my x minus 0.5. And then finding my length, we can see that the diagonal length squared equals the horizontal length squared plus the vertical length squared, or a squared plus b squared equals c squared. This is 9 plus 16, which equals c squared. We got 25 equals c squared. C will equal the square root of 25, and that's just 5. So the length of this is 5. This is a very important triangle to know, a 3, 4, 5 right triangle. It is one of the few triangles where like whole number lengths show up. Usually with triangles, right triangles, we do not see whole number lengths. All right, without the use of the coordinate grid, we could do pretty much exactly what we were doing. We have the point 12, 1, 10, -3. My x's go down 2, my y's go down 4. So I'll go down 1, and I'll go down 2 to get the midpoint. My slope will be -4, change in y over change in x over -2, which is just +2. Makes my perpendicular line have a slope of -1/2. Do we have a meeting?
At 10 or 15? At
10, great. And the slope is -1/2. And I'll have y minus -1. That'll be the change in the y's. This comes from the slope formula, equals my perpendicular slope, x minus 11. my length is my x squared plus my y squared equals my c squared. We can understand the square of my lengths, 4 and 16, equals the square of the diagonal. C will equal root 20. We have simplified root 20 before. It's root 4, root 5. Root 4, root 5 is 2 root 5. So that is my length, 2 root 5. Next one, we got -1, 4, and 3, 7. My x's will increase by 4. My y's will increase by 3. Go halfway. I'll add 2 to get 1. Also add 1.5 to get 5.5. So here's my midpoint 1 comma 5.5. Slope will be my change of my y's over the change of my x's. Perpendicular slope will be the flip of that and the opposite of it. Don't take the negative of both. It's just the negative of the whole thing. So like 3/4 is positive, negative 4/3 is negative. So I have y minus 5.5 equals -4/3 x minus 1. And my length, a squared, b squared, horizontal length squared equals c squared. 25 equals c squared. We should see that 5 again. 3, 4, 5. A square is split into two congruent isosceles triangles. The side length of the square is 6. Determine the length of the diagonal. Oh, well, look, I have a right triangle. I have side length 6. I'll have this missing diagonal length c. I'll have 6 squared plus 6 squared equals c squared. 36 plus 36 is 72. C will equal the square root of 72. Square root both sides. But 72 is 36 times 2. You can use your calculator to figure this out. So 6 root 2 is this length C. An isosceles right triangle has one side length of 5 and another side length of root 50. Find the other, third length. So this is interesting, like which one is 5? This can't be 5 and this can't be, the leg cannot be 5 and the other leg can't be root 50 because it is an isosceles right triangle. So we really have two options that we have to consider. Is our right triangle set up so that both of the legs are 5? Or is the right triangle set up so that both of the legs are root 50? So do we have the triangle where we have 5, 5, root 50? Or do we have the triangle root 50, root 55? Well, we can use the Pythagorean theorem to see which one works. A squared plus b squared, that's 25 plus 25, equals c squared. Root 50 squared is just 50. We can see that this works. The triangle with the legs 5, 5, and the hypotenuse root 50 does satisfy the Pythagorean theorem. Versus our other triangle, if I do root 50 squared, root 50 times root 50 is just 50. It's just squaring a square root. We get 50 plus 50 equals 5 squared, which is 25. This is not true, so this is not the situation. So the isosceles right triangle that we're considering is this 5, 5, root 50 triangle. Part of a line, y equals 1/2 x plus 1 forms the side of a square. To the corners, a square occurring with x is 2 and x equals 1. Okay, I want the 2 points. Sketch a diagram, find the other 2 corners of the square, determine the area of the square. So I'm going to use my equation. I'm going to find the 2 points. So when x is 2, I have y equals 1/2 times 2 plus 1, which is 1 plus 1, which is 2. So I have the point 2, 2. When x is -1, I'll have y equals 1/2 times -1 plus 1, which is -1/2 plus 1, which is 1/2. So I have -1 comma 1/2. Here is my line. Yeah. If we see that we go down 1.5 and we go left 3, we can kind of reverse that. So this is a Y change. I'm going to make this a Y change. I'm going to go up 3, 1, 2, 3, and I'm going to go over 1.5. And I get this point, which is 0.5 comma 5. And I'll do the same thing here, where I'll go up 3, 1, 2, 3, and I get to the 0.3.5, and I'll go to the left 1.5, 1.5. And I get negative 2.5 comma 3.5. Cool. So that's my square. Now, what is the side length of my square? Well, we have the a's and the b's. We have the a squared plus the b squared equals the c squared. The problem is we haven't done really a decimal squared yet. It's no big deal. Just know we won't be able to simplify our final answer. We'll have negative 1.5 squared, which is 2.25. 3 squared, which is 9, equals c squared. 2.25 plus 9 is 11.25. I'm going to say that the length of my square is the square root of 11.25. All right, that's it. Good review. Last question was probably tricky for you, but I don't think it's that crazy as long as you find some points. All right, peace.